welcome to Gifted Dance Science and Technology Chemistry class. I'm NC Joshua, popularly known as Oracle. Today we'll be looking at a calculational aspect of chemistry, which is how to calculate water of crystallization. What is water of crystallization? It is a definite amount of water that chemically combines with a salt. A definite amount of water molecules that definitely combines with a salt. And these water molecules that combines with salts help the salts to have one, a definite shape or a definite crystal, then two, the color. Now we have some example of these compounds or these salts that have water crystallization. We have one, we have copper 2, triazonitrate 5, we have copper triazonitrate 5, trihydrate, we have zinc triazonitrate 5, hexahydrate, we have copper 2 tetraazonitrate 6, pentahydrate, we have sodium triazocarbonate 4, decahydrate, and we have sodium tetraazolate 6, decahydrate also. So this contains 10 water molecules, this contains 10, this contains 5, this contains 6, and the other contains 3. Now there is something about this compound. They are said to be hydrated. Why? Because they contain water of crystallization. But if they lose some of this water of crystallization or their water of crystallization, they become anhydrous. So we have hydrated substances and we have anhydrous substances. Hydrated substances are compounds or substances that have water of crystallization, while anhydrous substances are substances that do not have water of crystallization. For instance, I have a graph like this. I have a graph like this where you have Na2SO4.10H2O. It has lost its water of crystallization and now it is Na2SO4. Now this is the point. This point is called the transition point or the transition temperature. For this particular compound, this place is 36 degrees Celsius. At this point, it loses 9 water of crystallization. Take note of this. This compound will lose 2. Now, look at what I'm trying to explain here. CuNO3 close bracket 2 dot 3H2O will lose 2 water of crystallization to form Cu open bracket NO3 close bracket 2. Likewise, Na2SO4.10H2O is going to lose 9 water of crystallization to form Na2SO4. So it's not going to lose 10, it will lose 9. Why? Because this one has a water of crystallization, a molecule of water in itself. So it's not a cake. It can undergo a chemical reaction because it contains a molecule of water in itself. So instead, this will lose 2, this will lose 5 to become anhydrous, this will lose 4 to become anhydrous, why this will lose 9, this will lose 9. Take note, it's not losing 10, it's losing 9 water of crystallization. Now the color of these salts are here: blue, white, blue, green. And the examination question can ask, what's the name of this salt? It can also be called green vitro. Green vitro. Now let's look at how these questions can be solved as regards water of crystallization. Now let's look at question number 1. Question number 1 says 5 grams of hydrated salt of barium when heated to a constant height gave 4.26 grams of anhydrous salt with a molecular weight of 208 grams. The number of water crystallization in the hydrated salt is this. I know some people have what they call shortcut formulas and what they've read concerning this, but I'll show you a simpler way that it can be solved. What is that way? Let's use the same concept we used for calculating empirical formula to solve out these questions. Now remember, the salt plus water molecule That's an anhydrous salt plus water molecule will give us hydrated salt. Now, so it means I have an anhydrous salt. What is the mass of the salt? So I have salt. Means I want to take the table, mass of salt, and I have of water. Now, question is, what is the mass? Now, this salt is the anhydrous. Anhydrous. Now, what is the mass of the anhydrous salt? Now, it says 5 grams of hydrated salt of barium when heated to a constant weight gave 4.26 grams of anhydrous salt. So, the mass of anhydrous salt is 4.26 grams. What about the mass of water it will give? The mass of water it will give is this is the mass of hydrated salt, while this is the mass of anhydrous salt. So the mass of water will definitely be the mass of hydrated salt minus the mass of anhydrous salt. So that will not be that will be 0.74 grams. So the mass of water is 0.74 grams. Now, what is the mole? Remember, you can go check my video on empirical formula. I've done a video on empirical formula so that you can understand what I'm doing properly. Now, the next one is the mole because I haven't done the mass. The next thing is the mole. Mole, we said mole is equals mass over molar mass. What is the mass here? Mass here is 4.26 over what's the molar mass of the salt? It was given to us. Look at it here. 208 grams. So I'll come over 208. That is the mole for this. Then what about this is 0.74 over 18. The molar mass of water is 18. Now, if that has been done, what will be the answer here? The answer here will be 0.0.02, while the answer here will be 0.041. 0.02, 0.041. Now, haven't know the mole, what's the next thing to do? The next thing to do is to find the mole ratio. The mole ratio. What's the mole ratio? We said the mole ratio is to divide each of the mole with the least number of mole. So what's the least number of mole here? 0.02 is the least number of mole. So I have 0.02 over 0.02. The answer is 1. While here I have 0.041 over 0.02. The answer is 2.05. Now this is 2. This is not a problem. You don't need to approximate. This is just 2. So it means that the salt ratio the water is 1 ratio 2. The salt ratio the water is 1 ratio 2. So the salt dot 2 molecules of water. So now it means that the number of water of crystallization in this salt is 2. The answer is 2. That is our answer. Thank you. Now let's look at question number 2. It says a hydrated salt of formula FeXO4.NH2O, that's iron 2 tetras over 6 NH2O. So we want to look for what is N in our question. Contains 45.3% by mass of water of crystallization. Calculate the value of N. Now remember that it will always be the anhydrous salt plus the water. That's what will give us the hydrated salt. So it's this place that we are dwelling on. Now, what is the first thing we are looking at? We are looking at what is the percentage composition. Now we are not giving masses like the first question. Now we are giving percentage composition. Now read again with me. A hydrated salt of formula FeSO4.NH2O contains 45.3% by mass of water of crystallization. So the 45.3% is for the water. So I'll come over here and put 45.3%. So if 45.3% is to water, what will not be to the salt? What will not be the percent of the salt? It will be 100 minus 45.3. That will now give us 54.7%. Remember, they gave me this. I subtracted from 100% to now get this. What's my next thing I will do? My next step is to find mole. Mole will now be percentage composition over molar mass. So for this place, I will have 45.3 over 18. What about for this place? I will have Fe plus X plus 16 times 4. So I'm saying that I will have Fe plus X plus 4 bracket O. So it is now 56 plus 32 plus 16 plus 4 times 16. So everything here will give us 150. That's what we'll get there. So if that's 150, so this will now become 150 grams over, sorry, it will become 54.7 over 150. So this is the molar mass of this. This is the percentage composition of this. So what is now our value? If this is divided, I will have 0.365. Then I will have here 2.517. 2.517. That's what I will have here. So this is the mole of this. This is the mole of this. So what's the next thing I will do? I will find the mole ratio. If you have no understanding of empirical formula, visit our video about empirical formula to get good stability on how to calculate empirical formula. Now, what's our mole ratio? Mole ratio is dividing the individual mole with the least mole we have. This is the least mode. This is smaller than this. So what becomes this? I have 0.365 over 0.365. That gives me 1. What about this? I have 2.517 over 0.365. This will give me 7. So what is now my compound? My compound becomes FeSO4 dot, what is now N? N becomes what now? 7H2O. That becomes the answer to this question. Thank you. Now let's look at question number 3. Question number 3 says, if 0.5 moles of magnesium tetraoxosulfate 6 XH2O has a mass of 2 grams, calculate the value of X. Now this is a very confusing question. Remember, this is not 1 mole. So because this is not 1 mole, we have to solve for a mole of this sort. So to solve this, I would say 0.5 mole has a mass of has a mass of 123 grams. Therefore, 1 mole 1 mole we have the mass of X. What is X equal to? X will be equal to 1 times 123 over 0.5. That will be 246 grams. So I cannot tell you that 1 mole, that's N, 1 mole of MgSO4 dot XH2O is equals 246 grams. That's what it's equal to. Now, if that's equal to this, what is now the value of X? Now what our question is asking us. What's the value of X? How will I solve this? It's very simple. I will say that this is Mg, this is Mg plus X plus 4 brackets, 4 brackets, O plus X 18 is equal, this is 18. Water here is 18. 2 plus 16. X 18 is equals 246. That's what it's equal to. Equals 246. So what is Mg? Mg is 24. So that's 24 plus 32 plus 64 plus 18x is equals 246. What's the next thing? Is to add everything up. They have 246 minus 246 minus, open the bracket, 24 plus 32 plus 64. Everything is equal to 18x. So if you add up this is already that's 10, 120. That's 246 minus 120 is equal to 18x. So this is now 126. 126 equals 18x. So we have 126 divided by 18. So 126 over 18 equals x. X equals 7. So it means that the water of crystallization of this salt is 7. Magnesium tetraoxide 6 heptahydrate. I think that's Epsom salt. Thank you.